All right, now we're going to get into sketching the graph of the polynomial. You're going to be doing this by thinking about end behavior and sometimes also thinking about, if necessary, the multiplicity, the zeros and their multiplicity. Okay, so let's look at question number 29. All right, this one's nice because they have it already multiplied out, already factored out, which means that it's easy to get your zeros. So you know your zeros, the zeros are going to come from those factors. So you're going to get a 0, a 1, a -2, and a 5. So it should have 4 spots where it crosses the x-axis. And each of them have a multiplicity of 1 because each of those factors just occurs one time. So you know it's going to pass through smoothly. All right, now let's think about the end behavior of this polynomial. So this is not already multiplied out, but you can imagine if you did multiply it out, see how you would have x times x times x times x. Take all the firsts. They're all to the first power. Of course, there'd be other stuff, but we don't care about the rest of it. We just care about the fact the leading term would be an x to the 4th power. So that should mean, since it's positive, so it's positive, so even though there's more, we don't care about them. It's positive x to an even, so we know it should do this at the ends. So really, we could have just looked at that because we can rule out all the rest of them because they don't have the appropriate end behavior. And then if you did zoom in on that, you can see that it crosses in 4 spots. And there should be a way for you to blow that up when you're looking at it in case you want to confirm that you're on the right track there. So it has to be that one, okay? All right, now let's take a look at this one. Let's start with end behavior because maybe we could rule it out. Now, when you do this for me, you're going to have to actually get a good sketch yourself. So you're not just going to be doing multiple choice on all of them. So the leading term for this one would come from all the firsts. So -1/2 times x times an x to the 2nd power, because you see that exponent there, and then times another x. So that means I'm going to have a -1/2 x to the 1, 2, 3, 4th power. Okay, and there would have been other stuff. I just don't care about it. And then because it's negative with an even exponent, I know it has to open down. So that means I'm toying between A and B. Okay, so I know it's one of those two. I know these are out. All right, now when I'm looking at it, I can look at the zeros. So I get a -4 as one of the zeros, 3, and -1. So let me write this down here. So the zeros on this one are -4, 3, and -1. All right, let's think about the multiplicity on each of these. So -4 has an exponent. The factor associated with the -4 has an exponent of 1. The factor associated with 3 has an exponent of 2. The factor associated with the -1 has an exponent of 1. So this is going to be like a line. This is going to be behaving like a parabola. And this one's going to be behaving like a line. So it should pass through at -4. Also, it should just cross at -1. Okay, but then at 3, it should bounce. Okay, so I have to think about the scale on this. Since it has the x-axis from -10 to 10, then that means each tick mark is 2 units. So this looks like a 3 right here that's bouncing, where over here the 3 is way up there. That can't be it. So it's a +3 bouncing, and then here's the -1. It's going through smoothly. Here's the -4 going through smoothly like a line. So it should be this. Okay. All right, let's try some more. So here's one I'm supposed to graph. All right, so I can get the zeros easily. So the zeros would come from what causes each of these factors to be 0. So that one would be 0. This one would be 3. This one would be -2. So 0, +3, and a -2 would be my zeros. Then multiplicity, that would be the exponent on each of those factors. So it would be multiplicity 1, then 3 has multiplicity 2, and then -2 also has multiplicity 2. So these two right here should touch and turn. They should bounce. They should be like a parabola. And these should, right here, this one should just cross the x-axis. Okay? Now, let's think about the end behavior of this one. Take all the first. -x times x to the second times another x to the second. Remember to include the exponent when you do that on these. If you were to multiply this out, it would have been an x squared minus 6x plus 9. If you did multiply that one out, it would be x squared plus 4x plus 4. You don't really have to multiply it all out. You just need all the firsts. See how it's negative and how there's 5 x's being multiplied together? So if it's negative out in front and odd, it should basically be falling. Okay, and the end should open in opposite directions. Okay? So it can't be this one, and it can't be this one. So you're narrowing it down to B or D. Now, which one of those it is, you have to be careful about the scale and make sure you're reading it carefully. So it should cross the x-axis at 0, 3, and -2. Okay. All right, so when you look at these two, let's see, I don't think I can make it any bigger. I think that's as big as it gets. All right, so it's going to be this one, isn't it? Because here's a -2, here's a 0, and here's a 3. When I look over here, that's at +2. Okay, but remember your zeros are what cause the factor to equal 0. So x plus 2 equals 0, then x would be -2, wouldn't it? So it's not that one. It's got to be this guy. And then let's just confirm that the end behavior is what it's supposed to be. Okay? So on that, we know that at -2, it should bounce like a parabola, and it does. We know it should pass through at 0, and we know it should bounce at 3. So that fits. Okay? All right, now let's approach this one like it wasn't multiple choice. Okay, so let's pretend you didn't have any of these and you're trying to get the graph. Okay, so what you would do, let me see if I can get that out of there. Okay, so what you would do is, if it wasn't multiple choice, you would think about the end behavior like we did, and you would get the, the -x to the 5th power. So you would take the -x times the x to the second times the x to the second. You would get the leading term to be -x to the 5th, so you'd be thinking this. Okay? Then you'd think about your zeros and their multiplicity. So you'd set each of those factors equal to 0, and you'd find what the zeros would be. Okay, so that's going to be x would be 0, x would equal 3, or x would equal -2. Then you're going to look at the exponent on those factors, okay, and you're going to see that the exponents, which is the multiplicity of each, okay, this one would have a multiplicity 1, this one would have multiplicity 2, this one would have multiplicity 2, okay. So then what you're going to do at that point is you're going to draw your x-axis, and you're going to locate the 3, and you're going to plot the x-intercept of 0, and you're going to plot the -2. Then you're going to use this information right here. You know that when you are way to the left, it has to start from above. Then it's going to come and need to have -2 being an x-intercept. And so you have to think about when you hit that, it has to bounce like a parabola, right? Because of the 2. So you're going to come in here and make it bounce at -2. Then you know it has to turn around because it has to go through the x-axis at 0, and when it does, it has to go through smoothly. So you're going to let it go through smoothly. Then at some point, it's going to need to turn around, and when it comes back around and it hits the 3, we have to decide whether to go through or bounce. That's what the exponent of 2 says, is it needs to look like a parabola there. Okay. Now we're really not making a claim about how high up or how low down these other what appear to be special things are. Just leave the y-axis without a scale on it. Okay. And there you have it. Okay. All right, now the y-intercept would have been 0, so we know it is crossing at 0, because if I did plug in 0 everywhere, right, this would have caused the whole thing to be 0. Okay, so then that would be your graph. That's what you would need to show. Okay. All right, so we'll try these other two as though we're doing them ourselves and not just looking at the multiple choice answers. All right, now this one right here is a bit of an issue because it's not in factored form. It's also not in descending order, so this is really negative x to the third plus 4x squared. So the leading term is negative x to the third. So you know your end behavior. Because of that negative x to the third, you know it has to be basically falling. And the ends need to be in opposite directions. Then what you would do is you would take this expression right here and you would factor. So I'm going to pull out a negative x squared. What's left would be 1 more x. Here I would have a negative 4. Then I'm going to notice that this being 0 would be one of my zeros, and then this being 4 would be my other one. And then I consider the exponents on those. So these are the zeros here. And then I'm looking at the exponents on the related factor. That one has a 2. That one has an understood 1. So then I would think about it like this. I would sketch my graph. I would put 0 and 4, put dots on those on the x-axis, because you know those are the x-intercepts. Then I know, because of the end behavior, that it has to start from above, and then I'm going to be approaching this 0. Okay, when I do, various things could happen. It could pass through and wiggle, or it could bounce. Because it had a multiplicity of 2, I know it's going to bounce. It's going to have to turn around at some point because it has to then get to 4. And then I think about how it behaves right there at 4. It's going to behave like a line, so it should look something like this when I'm finished. Okay. So really, if we did have the multiple choice options, we would know it couldn't be A or D. It would have to be B or C based on the end behavior. But then looking at how it needs to cross the x-axis at 0 and positive 4, this negative 4 right here would be what would rule that one out. Okay. All right, let's try another one. And let's try it. This one is already in factored form, so I can see my zeros easily. They are 5, 4, and 2. I also can get the multiplicity because it's already in factored form. I can see that I'd have a multiplicity 1 on both 5 and 4, multiplicity 2 on 2. All right, the other thing I need is the leading term, and to get the leading term, I'm going to take all the firsts. So I'm going to take x, which is just to the first power, then an x to the first power, but then an x to the second. So the leading term would be x to the fourth, which means it should do this. Now we're going to do this pretending we don't already have the multiple choice answers, because we already know which one it would have to be. So if you were doing this yourself, you would draw your x-axis and you would put those x-intercepts on there. So 4, 5. So it's going to cross, it's going to have an x-intercept at 2, at 4, and at 5. Okay. Now, I know it has to open up. And so I'm going to be coming from above. Okay. And then I'm going to wind up having to get to the 2. When I do, it's got to bounce because it has multiplicity 2. So it has to bounce. Then it would have to turn because it has to hit 4. And 4 has multiplicity 1. So it has to go through smoothly. It would have to turn to hit 5. And it has to go through smoothly because it has multiplicity 1. And then I like the result because everything's consistent. Now, This y-intercept up here I could find to get the y-intercept and be able to label that. I can put a 0 in for x, or I can take all the n's and multiply them together. So this would be -5 times -4 times parentheses -2 squared. So it turns out to be positive 20 times a positive 4 turns out to be 80 when I'm finished. Okay, so that means it's going to cross way up here somewhere with a y-intercept of 80. Okay, so that's graphing polynomials by using both end behavior and considering the zeros and their multiplicity.